Let's look at some more examples of derivatives. Let f be a function from the open interval 0 infinity into r. Forgot my codomain there. So, excuse me. Such that f of x equals the square root of x. Now remember, the square root of x is x to the 1/2 power. Commit that to memory. That's a handy thing to know. For example, also like the cube root of x would be x to the 1/3 power. The fourth root of x would be x to the 1/4 power. The fifth root of x would be x to the 1/5 power, and so on. Guys, commit that to memory. Those things are handy to know, or commit those things to memory. So, we're going to let c be in the open interval 0 to infinity. So f is just a function from the positives into the reals, and c is just some positive real number. We get the limit as x goes to c of the square root of x minus the square root of c over x minus c. That's equal to the limit as x goes to c, the same numerator, over. Now, by difference of squares factoring, by a type of factoring akin to difference, it really is difference of squares factoring in a weird way. This isn't really x squared and this isn't c squared. This is just x and this is just c. But what it is, guys, you can think of x as the square root of x parentheses squared, and you can think of c as the square root of c parentheses squared. So what we can do is, you can imagine this as radical x squared, and this is radical c quantity squared. So what we get is we can do difference of squares after all. Radical x parentheses squared minus radical c, close it off in parentheses and square it, equals radical x minus radical c times radical x plus radical c by difference of squares. Okay, that feels a little weird, but it's true. You can do this. That's a trick. You kind of just got to get used to some of these tricks. I know if that was heavy going, I apologize. But anyway, you can cancel this. Now you can cancel the numerator with this guy here, and you just get limit x goes to c of 1 over radical x plus radical c. But no, that was the beauty. That was the golden step, was when we canceled this term with this term. Now we have continuity. Remember, composition of continuous functions is continuous. Now, this isn't really a polynomial anymore, but we still have continuity. Roots are continuous, and the sum of roots are continuous. Products and sums of continuous functions are continuous, and so on. So we can throw c into x, and we get 1 over radical c plus radical c, but that's just 1 over 2 radical c. And by the way, you can write that, you can take that, that radical c on the bottom can be thought of as c to the negative 1/2 power. That's another thing you need to get used to. As if you didn't have enough on your plate already, right? But anyway, let's go to this one. Now let f be a function from the negative numbers into the reals. And again, I forgot my codomain, sorry. Such that f of x equals the square root of negative x, which is negative x parentheses to the 1/2 power. Why am I putting a negative here? X by himself is negative, so I need the overall guy, negative x, to be positive. For example, x might be negative 5, so the negative x will be positive 5 here. Remember, we only want to do the square root of positive numbers overall. So we want to do the square root of negative x where negative x is positive. And we're going to let c be a negative, and we get f prime of c is radical negative x minus radical negative c over x minus c. And now the trick on the denominator, I'm going to pull a little trick. I'm going to filter out a negative 1, and I'm going to turn this into negative x minus negative c, which is really negative x plus c. But guys, let's write it like this. I want to keep it as negative x minus negative c for the sake of convenience and utility. What it is notice we have f of x minus f of c over, well, let's just go with it. Yeah, that's not the best way to put it. Let me just stay with this instead. So we got radical negative x minus radical negative c over negative x minus negative c. Okay. So, well, we've got f of x minus f of c over negative x minus negative c. But let's just go with it for now. But now that's still confusing because we'd really like to have x minus c, not negative x minus negative c. But now that's really, let's just leave it like this. Never mind f of x just yet. We'll go there in a minute. I kind of did that prematurely. But the only thing I want you to take away from this very first step here is that I took out the negative 1 and I wrote it as negative x minus negative c. That's all you need to know for now. The next thing I do is, see this negative 1 right here, guys? I take it out here as a minus sign. So this negative sign is understood to be a multiplier of neg 1. Okay. Now, you're probably still not feeling all that warm and fuzzy inside, but now here's the hard step. So I have the same old negative lingering out here, the same limit x goes to c. I have the same old numerator, but now I do difference of squares. You remember, negative x is a positive number, negative c is a positive number. So what I do, again, by a similar difference of squares technique, I do radical negative x minus radical negative c times radical negative x plus radical negative c. Because negative x overall is positive, negative c overall is positive. So there's that. Okay, and now this probably feels funny big time now. But anyway, you can cancel the numerator with this piece of the denominator with the numerator, and you just get negative limit 1 over the sum of these two. But then by continuity, you can throw c into here, and so you get negative 1 over 2 radical negative c, which can be thought of as negative 1/2 times negative c to the negative half power. Because c by himself was negative, so negative c is overall positive, okay? Now, so negative c is a positive number. That's all I'm saying. Negative c is a positive number, and so negative c to the, now neg c to the neg half would still be a positive number. But then you take that positive number and you multiply it by the negative 1/2 right here where my cursor is, and you're going to end up, this overall term here is going to wind up being negative. Just this whole term right here, that is. But anyway, there's that. I know that was a little bit heavy going. Now this difference of squares step, here's a way to think about it. If I replace negative x with p squared, negative x is positive after all, so let's replace negative x with p squared and replace negative c with q squared in our mind, not on paper, but in our mind. So replace negative x with p squared, negative c with q squared. P squared minus q squared is p minus q times p plus q. Feels a little funny, but you can do it, and you need to do it. And on this next example, if I have like f of x equals x to the 3/2 power here, and again, I'm staying on the positives, then f prime of c, if c is a positive, as we specified on the previous page, yeah, up here, yep, c is a positive right here. So f prime of c, now it's this limit right here, x to the 3/2 minus c to the 3/2 over x minus c. But guys, remember, x to the 3/2 is x radical x. It's x to the 3/2 is x times radical x, aka x radical x, or x times the square root of x. That's what x to the 3/2 power is. So now, now here's the deal. But I'm not going to really go there yet. What I'm going to do is sneaky. X to the 3/2 power can be thought of as the cube of x to the 1/2 power. So we're taking the square root of x, and then we take that, or take that radical x, and we cube it. That's how. That's another way to get x to the 3/2 power, because radical x times radical x times radical x is x radical x. You can do associativity and all that. But anyway, so by difference of cubes, you can think of this as p cubed, think of this as c cubed. So p cubed minus c cubed is p minus c, and then p squared plus, let's do p cubed minus q cubed is p minus q. Here's the p, here's the q, and then p squared plus q times p plus q squared. Okay, so p is the square root of x in and of itself. Q is the square root of c in and of itself. So this is p cubed, this is q cubed. So p minus q, p here, p squared here, q times p here, q squared here. Okay, q is the square root of c, p is the square root of x. There we go. Whew. Now on the bottom, we do that sleight of hand again. By difference of squares, I get radical x minus radical c and radical x plus radical c. Remember from the last, from 2 examples ago, you can factor x minus c as this guy times this guy. But now the golden goose is that this is going to cancel with this. This radical x minus c is going to cancel with this radical x minus c. And you just get the numerator unparenthesed over the denominator unparenthesed because we don't really need the parentheses anymore. But then we have continuity. You can just throw c into this, and you get c plus radical c times c plus c over radical c plus radical c. But c is positive, guys. So radical c squared is just c in the middle there. So rad c times c is c itself. So we get c plus c plus c. That's just 3c. And radical c plus radical c, that's 2 times that radical c. So we have 3c over 2 radical c. But hey, c divided by the square root of c is just the square root of c up top. So we get 3 times the square root of c over 2. Remember, by the law of exponents, this is c is to the 1 power up here. Radical c is to the half power down here. You subtract the exponents, top minus bottom. 1 minus a half is a half up to, and so c to the half is radical c. But now by the laws of arithmetic, we can yank that radical c out to the side. You know, as long as it's in the numerator, that is, we can yank it out to the side like this by the laws of algebra. We get 3 halves radical c. Or you can think of that, if you want to go back to exponent form, you can stop here. Your professor, I think, would be satisfied, or whoever your instructor is would be satisfied with either this or this. You would have to ask him or her. He or she, that is. You would have to ask him or her where he or she would be satisfied. That's up to him or her. I can't make that call for him or her. But they may be satisfied here. But if they want you to put it back in exponent form, you'd do this right here. The square root of c is c to the 1/2 power. Again, I can't speak for your professors, obviously, okay? If he or she wants to do it in a certain way, then you'll have to do it that way. But anyway. Now, let's look at something different than radicals. If f is a function from the non-zero reals into the reals, and I keep forgetting my codomain. Sorry about that. Such that f of x equals 1 over x, which is x to the negative 1 power. And let's assume that c is just any non-zero real number. We get f prime of c is f of x minus f of c. That's going to be 1 over x minus 1 over c over x minus c. It's always yucky to have fractions nested within fractions, but anyway. Now, by common denominator, we turn 1 over x into c over cx. We turn 1 over c into x over cx. And then we just get the same little x minus c down here. And by the laws of fractions, now that we have common denominator, we can bring the numerators together, c minus x over cx, and then that over x minus c. But by the laws of algebra, now here's the part where students scratch their head, but you can do this. You take the cx down here and you multiply it into the whole term, x minus c, but you'll have to put either parentheses or brackets, just whichever you prefer, around x minus c. You will need to put something, though, because you're multiplying distributively by x minus c. So the cx comes down here as one denominator. And then, but hey guys, now x minus c, you know what? You can really cancel c minus x and x minus c as negative 1, because x minus c is a negative 1 multiplier of c minus x. They're within negative 1 of each other. They're the negative of each other. Like if c minus x equaled 5, for example, x minus c would equal negative 5. But anyway, I kind of I delete that. Now what I decided to do instead was, well, I just did the limit x goes to c. I did the product of the limit as the limit of the products as long as everything exists, and it will exist here. Now the limit is x goes to c of 1 over cx. Since c is positive, this limit is we're just going to be continuous. That's just going to be 1 over, you can plug c into x here, we'd get 1 over c squared, which that's fixing to come along. So the limit of the product is the product of the limits. In particular, you can think of this guy as 1 over cx times the fraction c minus, for this difference quotient here, without ignoring the limit for a minute, you can think of this as c minus x over x minus c is one fraction times as another fraction 1 de facto over cx. So c minus x over x minus c is one fraction times 1 over cx is another fraction. And again, remember, when there's de facto, when there's no one left in the numerator, 1 is the default number. By de facto, I mean default. 1 is your so-called default number. Okay, so we get limit x goes to c of 1 over cx times limit x goes to c of c minus x over x minus c. But that's just, that first guy, this guy right here is 1 over c squared, and this guy right here is just negative 1. These two cancel and make negative 1, but the limit anything of negative 1 is just negative 1, so we multiply these two, 1 over c squared times negative 1, that's just the negative of 1 over c squared. You could put the negative either up here or down here without parentheses, though. If you put it down there, don't use parentheses. But I'm just going to leave it out here to the side. But remember, 1 over c squared, remember, you can denote that as c to the negative 2. Now, we had this negative that was already dangling out here. And remember, 1 over c squared, we write that in shorthand as c to the negative 2. That's the very definition of c to the negative 2, 1 over c squared. This other negative, on the other hand, it was just dangling out here. So even like 1 over z cubed would be z to the negative 3 power. Or 1 over z to the 5th would be z to the negative 5 power. So on and so forth. And in a similar fashion, I may, I'm running out of time, but in this example, I do f of x equals 1 over x squared, which remember, that's x to the negative 2 power, and let c be a non-zero number. You know what? On the last one, you remember when I told it, c, I said, now c doesn't have to be positive. Let me go back up here a minute. I told you if c was positive, it doesn't have to be. It could be negative. The only restraint is we just didn't want c to be 0. So sorry about that. I was too strict. C is just any non-zero number. And it's okay. We're not doing square roots here anymore. We're doing even integer powers. So C can be negative. It's okay. We're using integer exponents, whether it's negative integer or positive integer or even 0 as your exponent. But anyway, C is not 0 itself, so that's fine. So C could have been negative down here, and everything would have pushed through just fine. So the only restraint we made on C was that it's not 0. And we're going to do the same thing down here. C can be negative or positive just so it's not 0. So we get f prime of c. That's what we're wanting to find, the derivative of f at x equals c. That's going to be f of x minus f of c over x minus c. We get common denominator. We bring the fraction together. We bring the c squared x squared down here in a similar fashion that we did the last example. And we break the limit apart in a similar fashion. We plug c in for x in a similar fashion. Now, the only difference is on the numerator, we have to do a difference of squares. That c squared minus x squared, it factors into this. But then, now c squared times c squared, that's c to the 4th down here. You know, we add the exponents. And remember that c minus x and x minus c is going to just make a negative 1. They're going to cancel off to a negative 1. But anyway, so we get, we break this up. The limit of the product is the product of the limits, and likewise for quotient as long as denominators are non-vanishing. But anyway, now you can't take x minus c out. You've got to leave c minus x and x minus c. Guys, they have to stick together. The same was true up here, by the way. You can't, these got to stay together because you get the denominator limits towards 0. So, but this limit is negative 1. This limit is 2c, and this limit is, we've already done it, 1 over c to the 4th. Let me continue this example in the next video. I'm out of time. Thank you.